Today we're going to make a little drawing application, and we're going to be able to draw with different fruit. So it's a very simple example of object instantiation and a rudimentary user interface that allows us to move around in 3 dimensions and continue working on our drawing, which is sort of rudimentary kitbashing, I would say. So perhaps without further ado, let's just enjoy the tutorial. We're going to start with an empty project. First thing I want to do is to import a custom package which I prepared for you. It's available if you follow the link in the description of this video. I'm going to open it and agree to import all the assets that are contained in it. What's going to happen is you're going to end up with these additional folders in your assets folder, and from now on you can use those things. So we're going to use from the prefabs folder. Let's start with a strawberry. This is what it looks like. It shows up in the scene, and let me adjust the scene a little bit first. So I'm going to change the appearance of the whole thing by adjusting camera settings, change it to a nice color, let's say, as a background, maybe changing the aspect of the whole thing like that. Also in camera settings, I'm going to zero it so that everything is nice and central. I'm gonna keep this offset here from the object. You can see it here, this distance. Okay, so this is where we are. First of all, we're going to make a little exercise about instantiating objects, meaning that we're going to learn how to do this. So basically dragging and dropping an object into a scene, but with the code. All right, so for that, let me erase the strawberry again and go to the assets, create my first script here. It's going to be called, let's say, add things, like so, and I'm going to open it in Visual Studio. Let's wait a little bit. Okay, there we go. Okay, there we are in the Visual Studio. So if I want to use an object from my assets folder, I'm going to need to, in a script, I'm going to need to create some kind of reference to it. So we're going to create a game object called fruit. And in order to be able to easily assign something from outside of the script to that variable, I'm going to declare it as public. So let's see what happens if we just do this. I'm going to save, go back to Unity, and make sure that my script is active in the scene. So for that, my usual practice is to create empty game object. I'm going to call it, let's say, a script holder, like so. And I'm going to add my component, my script component, to it. So right now I know that it is in the script, and as we can see, it expects me to drop here some kind of game object. So I'm going to go to the prefabs, take my strawberry, and drag and drop it there. So right now I know that under this name I have the strawberry prefab. So let's learn how to instantiate and it's pretty straightforward. So what we're going to do at the start, we're simply going to instantiate, there we go, the strawberry, which is under the name fruit, and let's not add any additional parameters to that function. Let's just end the line, save it, and let's see if that works. Okay. So if everything is fine, we should have the strawberry showing up the moment our game starts. And there we go. It's here. Okay, that's fantastic. So that means that we are able to instantiate an object whenever we want. And in fact, if we look at possible variables here, we can create it in a particular position and with a particular rotation. And this is what we're going to do next. But before that, let's engage a little bit in the interaction. So first of all, what we want to do is to be able to detect the user clicking somewhere in the scene, right? So we're going to use a very simple syntax for that. In the update part of our script, we're going to say if input.mouse get mouse button down. So that means whenever the user presses the button, and we have to specify which one. So let's say 0, which is left mouse button. Do whatever is in this parenthesis, right? And in order to check whether everything is working fine, it's very useful to debug.log there we go, some kind of message. So what this is going to do, or it should, whenever the mouse is pressed, is going to drop a little line in the console so that we know that the script is working. Let's check this. There we go, voila, you can see right there that we have our tag and a little message here. So we know we're clicking, that's great. Let's move on. What we want to do is we want to use a technique called raycasting. And raycasting means that we are going to shoot rays in the scene from the camera right there, and we're going to check whether these rays intersect something in the scene, like the strawberry that we're going to have there, or any other object. So for that, let's go back to our script, and let's first create a ray. So ray, let's say like this. So I'm declaring that under this name from now on, I'm going to have something of a type ray, and let's say we're going to use camera.main, so that's our main camera, and there we go, we have a function screen point to ray, so it's going to convert whatever our input mouse position gives us into array. Okay, that's fantastic. So why not checking what array is? In fact, instead of clicking, I'm gonna say, you know, just display whatever whatever is under this array variable. Let's try that. So the strawberry shows up, and there we go. So what array is something that has an origin and it has a direction, right? And you see that there are different numbers there. We don't know exactly what they're doing, but we can assume it has something to do with a position in a scene relative to the camera. So now, what I need to do now is create another conditional statement. And in this one, I'm going to figure out whether we're raycasting or what happens if the raycast command hits something. So if physics, so this is Unity's inbuilt physics engine dot raycast, and I'm going to raycast using my ray, then tell me that I indeed debug.log hit something. There we go. So let's see what's going on here. I mean, let's explain first. So if we are clicking the left button, we are going to create a ray from main camera to somewhere into the screen space. And then if that ray is hitting something, so it intersects with a given object in a scene, we should get a message that we indeed are hitting something. Let's save and go back to Unity. Okay, so there we go, we have my array, and now if I'm on a strawberry, I can see here in the console that indeed I'm hitting something. Well, that's fantastic. So now the next step is going to be a little bit more specific. So, well, it's not only that we want to know that we hit something, we want to know what did we hit and where. And for that, as you can see here, IntelliSense gives us a possible other options. We could store whatever information is generated by this physics operation into a variable. So why don't we do that right now? Let's just say raycast hit. There we go. So what we're saying is this name is going to stand for something that is of a type raycast hit, and it's basically a container for all sorts of useful things that a raycasting operation generates for us. So hit info. So basically what's going on here is, let me explain that. So physics performed a raycast using my ray and output that into this variable. So that's what's going on. And now instead of being so generic, we can be very, very specific. So we can say hit info dot, well, how about collider, right? So this should give us a name of the object that we're hitting. Let's try if that works. So there we go. Strawberry clone, Unity Mesh Collider. Fantastic. So we know that we are hitting a particular object. Check this out. We can actually detect the position or point that we're hitting this object at. Right? So you can check this out for yourself. Now, what I want to do is to add more strawberries at this point. So let me just comment out these debug options and instantiate my fruit at the point hit info dot point. There we go. And now it wants us to provide also the rotation of this newly created object. So for that, I'm going to keep it simple, and I'm going to say quaternion dot identity. There we go. explanation of what quaternions are is beyond the scope of this tutorial. However, you can easily check this somewhere else on YouTube. So, okay, what this should do is it should instantiate our strawberry at the point that we're clicking whenever we're clicking. So let's save this and check this out. And voila. So that's quite perfect. Perhaps what we could do now is to make this a little bit better here and adjust the rotation of the object so that it's normal to the vector, so that it basically inherits the normal at the point that we're clicking. So we're going to do this in just a second. Okay, so let's just do this. Instead of quaternion identity, we're going to use quaternion look rotation. No, forward. No, I don't remember how it's called. Okay, look rotation. There we go. And we're going to derive it from hit info dot normal. There we go. Just have to make sure that we have right amount of parentheses, like so. Save our script, go back to Unity, and let's see if that does the job. So we have this very nice rotation adjusted to the previous object. Okay, well, that's quite great. Now, the next step here is going to be about using different objects. So not only the one that we provided first, but basically to have a basket of fruit and to instantiate all the different ones that we have available. So we have 4 different fruit here. We're going to create this basket by basically declaring this game object. Instead of a single one, we're going to declare it as an array, and you see that it immediately generates an error because from now on we need to specify which from this basket we're going to use. So in this case we're going to use object 0, and in this case, let's see what we're going to use. For now, I'm going to say 0 and adjust everything in the editor so that we can work with this. So let's take a look at our script because something changed here. So our fruit variable is not anymore expecting a single object. In fact, it became a list. And so now we can say that it's a list of, whoops, not 40, but rather 4 different objects. And we can simply drag and drop those different objects in the right place, like so. And now, in order to use it, of course, what we're seeing here is an index referring to this index here, right? So element 0 is element 0, 1, 2, 3 are the following elements. So as we know, anything that is a fixed number can be replaced by a variable or a function, whatever we want. So why not, every time we click, we're going to declare a random number and we're going to generate it. So random dot range from 0 to, well, how many objects do we have in a basket? Well, we can of course hard code it. We can say 4, but instead we can simply ask the basket itself. So fruit dot length. There we go. So this should give us the length of this list. And if that's the case, we're going to generate an index starting from 0 and ending at the fruit length, meaning that we should be able to derive or to instantiate randomly some object from the basket of objects that we have. Let's try that. Play. All right, strawberries, grapes, avocados. All right, so we can indeed instantiate all those different objects. It's fantastic. So the last step in this quick tutorial is going to be a little user interface. So what do we want? Let's take a look at our game so far. What we want is to be able to change the way we're looking at our scene, and the reason is pretty obvious. You know, that's it. So as you can see, maybe also in the editor view, let's take a look at this. Here we go. Clearly, we have a camera here, and we're adding objects. Well, they're gonna go towards the camera, and well, our game is over. What we want to do is to be able to draw in space. That's our objective. So in order to do that, we need to be able to move the camera around in a way that makes sense. And in order to do that, we're going to use a little trick. So what I'm going to do is I'm going to create a little camera rig, which is going to work similarly to a selfie stick. Let me show you what I mean by that. So I'm going to create an empty game object in the very center of the scene, right there. I'm going to call it, let's say, camera rig. And I'm going to make sure that my main camera is hierarchically dependent on it. So basically it's a child object of this one, right? What that means is, you know, my main camera is offset, you know, it has the, you know, this offset here, but now instead of being absolute, it's relative to this object here, meaning that if I move this object, my camera is going to move as well, and that's fantastic. But not only that, if I'm going to rotate this object, my camera is going to rotate around it. So what this is going to allow me to do is to move the camera at the offset that it is right now from the very center of the scene to any other point in the scene. And in order to detect that point, you can guess that I'm going to simply detect an object. So I'm going to be clicking on some objects and adjusting my camera position accordingly. So that means that we can actually reuse the technique we were applying for object instantiation here. Let me show you real quick what does this all entail. So I'm going to create a new script, which is going to be called, let's say, handle camera. There we go. No, that's not our script. I want, it always takes a while. Let's open this one. There we go, it's empty. Now, what I want to do is, instead of clicking left button, I'm going to use right mouse button, and that click should transport the center of my scene from one place to another. And so let's just be quick. Let's just copy the whole chunk of this code and paste it into the newly created script. There we go. And now let's just modify it. So we don't want to do any fruit stuff here at all. So I'm just gonna drop the instantiation thing. We don't need random numbers at all. We need raycasting. We need all this information. Now let's adjust it. So instead of clicking left mouse button, which is indexed by 0, we're going to use right one, which is under code 1. There we go. And what we want to do is change the position of the transform that this script sits on from one place to another. And in order to do that, I'm going to say this dot transform dot position equals, guess what, hit info dot point. Okay, is it that simple? Save this. Let's go out here and let's try to use our script. So what I'm going to do is I'm going to drag and drop it onto the camera rig, like so. I can double check that it's sitting there indeed. And let's see if I'm successful with this. So I can add objects, that's fine. And now let's try to press right. Whoa, okay. Okay. So I can move within the scene. The movement is a bit abrupt, I must admit. It's not very elegant, but still, it's some rudimentary form of navigation. So I would call this a success, and let's try to improve it. So I'm going to save that and go back here. So how about instead of doing it so abruptly, how about slowly or smoothly moving from one point to another? How about that? So instead of performing this operation on click, what we would need to do is to create some kind of movement. And as we know, update is a right place to, well, update things little by little, for example, if we want to. So we're going to do just that. Instead of going into this new place immediately, we're going to store this new place as a vector target. There we go. Oops, target, not dot, but underscore. So target position, we created a new vector. And what we're going to do here, instead of immediately changing the transform position, we're just simply going to save this information as a target position. Okay, so this is what happens on click. But in the update, we're going to say this transform position equals, and here's a little vector math. So vector 3 dot move towards, there we go, we have a function like this, and it asks us for the place we're at right now, the target, which we have, and the distance, the change, the increment by which we're moving. So let's try to use that. Well, our current position is in fact this. Our target position is our target position vector, and the increment is going to be, let's say, 1.1 unit. So let's save this and see if that works. So with this, I would expect that we're going to have, instead of abrupt change in the place of the center of the scene, we're going to have, there we go, an interpolated smooth transition. That's much nicer, much more friendly. Okay, that's great. So the last thing is going to be about rotation, because we not only want to move in one direction. It would be great if we could freely navigate in three-dimensional space. So for that, I have little user interface element prepared. We're going to do this with buttons on the side of the screen here. So let's create those. Game object, UI, button. Oh, it asks us for some stuff. Let's just obey. Okay, so we have a button. Well, I'm gonna make it a bit bigger. I'm going to lock it to the left side of the screen. And let's take a look at what's in it. I don't need the text at all because I have my user interface graphics. It's going to be self-explanatory. I'm going to drag and drop it into the source image. There we go. Looks much better. And I'm going to say that this button, just for the sake of clarity, is going to be called turn left button, like so. So I'm going to create immediately a copy of this one and call it turn right button, and lock it here to the right side of the screen. And now I'm just going to do a little dirty trick, because of course I could have two different images and assign left arrow to the left, right arrow to the right. I happen to have only one arrow, so what I'm gonna do is I'm just gonna say this, right? So I change the pivot place and I change the scale by -1, and that should actually do the job. So now we have arrows on both sides. Okay, good. Now let's do the rotation part, and that's in here. We're going to create well, a custom function, void turn left, like so. And in fact, we could just start similarly to what we did here. This transform rotation is, and here's a little quaternion math. So quaternion Euler 0 here. What we want to do is we want to add to our current rotation 90 degrees, right? And that's around y-axis, which is here, which is the second one. So this transform rotation dot Euler y plus 90. Oops. Some things going on here. 90. There we go. And z. Are we good? Sorry, 0. Okay, so what this should do is, let me explain it. We want to assign it to current rotation of this object, which is, just to recall our camera rig, a new quaternion, which is derived from Euler angles, which are x, y, and z. And we don't care about rotation in x, and we also don't care about rotation in z, but we do care about rotation in y. So what we're taking is current rotation and adding 90 to it. Let's see if this makes any sense. So I'm saving this, and now I'm going to assign this to our left arrow, and hopefully we're going to be getting some results. Let me double check. Of course, this needs to be a public function, otherwise we cannot work with it from outside of this scope here, outside of this script. Okay, so save button here. I'm scrolling down. On click, I'm going to add a function which, well, we want to interact with the camera rig because on it there is our script, and I'm going to choose from handle camera script turn left function, and let's see if this works. So I can draw, I can move, and I can rotate. And in fact, I'm rotating around the place that I am in right now, which is precisely what I want, right? So so now let's do the same thing that we did here, so that instead instead of a jump, it's smooth interpolated rotation. So I'm going to create a quaternion target rotation, like so. And again, here, instead of changing my current rotation immediately, I'm going to store whatever is the result of this quaternion operation here as a target rotation. And what I'm going to do in the update function, this transform rotation, is again quaternion rotate towards. There we go. So actually there is equivalent function for rotations. So from, well, this transform rotation to target rotation by, let's just give it some value, let's say 0.5, whoops, like that, and let's see what happens. So turn left is going to give us current rotation plus 90, and then in the update we're going to smoothly rotate towards that target. So save, let's go here, and let's see if this works. I can add, and I can rotate. And so my navigation works. So that's fantastic. The last thing I'm going to do here is just to add equivalent function for turning right. So I'm just going to go this, turn right, and then here I'm going to say minus 90. Save this, go back here, and just make sure that we have the right button also interacting with the camera rig. So on click to do, all right, camera rig, right there, handle camera, turn right. So I'm going to save this, and let's see if we're good. Okay, we can do that, and we can rotate. So we're free in space. So with this, our game is ready. I'm going to save this scene as fruit drawing scene. And that's the end of this tutorial. Thank you very much.